The tiny constellation of Triangulum is the sacred island of Sicily, immortalized in the heavens at the request of the goddess Demeter. The ancient Greeks saw in this strict geometric figure a divine symbol of absolute worldly harmony. But today, a grandiose spiral galaxy is located here, the most distant object visible to the naked human eye. Hidden within its depths is a colossal stellar incubator, where hundreds of massive suns are being born simultaneously right now.
Welcome. Today, we're going to turn our attention to the constellation Triangulum. Now, it might look modest in size, but don't let that fool you. This ancient celestial figure holds a place of critical importance in our understanding of the cosmos, one that stretches far, far beyond our own galaxy. You see, Triangulum isn't just some random collection of stars. It's actually a key object for modern extragalactic astronomy. It serves as this crucial landmark, really, that challenges us to look past the familiar patterns in our night sky and peer into the truly vast scales of the universe. So, here's our plan for today. We'll start with some celestial geometry, its basic profile. Then we'll zoom in on the main stars, the beacons of the constellation. After that, we'll take a look into deep space at something truly special. We'll also cover its history, from Plow to Myth, and we'll finish up with how you can find Triangulum in your own telescope. All right, let's dive into our first section, celestial geometry. Here, we're going to lay the groundwork by looking at its astrometric profile and the best conditions for observing it. So just how big is it? Well, on the celestial sphere, it carves out a precise area of 131.8 square degrees. Think of that number as our baseline for understanding its scale. But what does that number actually mean? Well, to put it in perspective, that size puts Triangulum in 78th place out of all 88 constellations. So yeah, it's definitely one of the smaller players in the night sky. But here's the thing. Despite its small size, it's incredibly easy to see for most people on Earth. It's fully visible from the North Pole all the way down to a latitude of -50 degrees. That covers almost all inhabited continents. It's only when you get to the very far south that it starts to dip low, just peeking over the northern horizon. Okay, moving on to our second section. We're going to zoom in now from the overall shape to the beacons of the constellation. This is where we get into a proper astrophysical analysis of its key stars. We're going to focus on 3 star systems in particular. First up, Beta Trianguli. It's actually the brightest one. Then there's Alpha Trianguli, also known as Metalla, which is a really interesting binary. And finally, we'll look at Iota Trianguli. Now, you might expect Alpha to be the brightest, right? But counterintuitively, it's Beta Trianguli that holds that title. It's a white giant, spectral class A5 3I, about 127 light-years away. And get this, it radiates 70 times more energy than our own sun. But what's really exciting for astrophysicists is that it's surrounded by a disk of gas and dust. That's a huge clue that we might be looking at a planetary system in the process of forming. Next, we have Alpha Trianguli, or Monotala. This one is a completely different beast. It's a close spectroscopic binary system. That means the 2 stars are orbiting so tightly together that you can't see them as separate points of light, even with a powerful telescope. We only know there are 2 because we can detect the shifts in their light spectrum. The main star is a yellow-white subgiant. But here's the coolest part. It spins incredibly fast, completing a rotation in just 1.74 days. This whip-fast rotation creates so much centrifugal force that the star is literally squashed at its poles. It's not a spear, it's an oblate spheroid. And then we have Iota Trianguli, which really shows you the amazing variety just within this one small patch of sky. For anyone with a backyard telescope, this one is a real treat. It's a double-star system that's pretty easy to split, and when you do, wow, you see this incredible color contrast. The main star has this beautiful golden yellow light, and its companion is this stunning emerald blue. Just a gorgeous sight. All right, we've looked at the stars inside our own galaxy. Now I want us to pivot and look much, much deeper into space. We're about to explore the most significant object within Triangulum's borders, an object that completely redefines the importance of this little constellation. But before I reveal what it is, let me ask you a question. What do you think is the most distant object in the entire universe that you can see with just your own eyes? No telescope, no binoculars. The answer, believe it or not, is hiding right here in Triangulum. And that object is the Triangulum Galaxy, M33. It's a whole other galaxy. It's the 3rd biggest member of our own local group of galaxies right after Andromeda in our Milky Way. It's about 3 million light-years away. That faint little smudge of light you might see on a perfect night,
That's light that has been traveling for 3 million years, marking the absolute limit of what the human eye can see.
But it gets even better, because inside this already incredible galaxy, there's a phenomenon called NGC 604. This is a gigantic region of ionized hydrogen, an H2 region, which is basically a colossal stellar nursery. We're talking about one of the largest, most active star-birthing regions in our entire cosmic neighborhood. It's hard to wrap your head around just how big and bright this thing is, so let's try an analogy. Imagine we could pick up NGC 604 and place it where our own, more familiar Orion Nebula is. If we did that, it would shine brighter in our night sky than the planet Venus. It would be just this huge, dazzling cloud of light. Absolutely stunning. Okay, so we've covered the astrophysics. Now let's switch gears and look at the human story. In this section, From Plow to Myth, we're going to trace how people have seen and interpreted this group of stars through history. And what's amazing is how its identity has changed over time. If you go back to ancient Babylon, they called it Mul Apin, which means the plow. Its appearance in the sky told them when it was time to start planting. Then the ancient Greeks came along, and with their love of geometry, they saw it as Deltoton, the celestial version of their letter delta, and that's the interpretation that was made official, so to speak, by Ptolemy in the 2nd century. The Greek myth behind it is also pretty fascinating. It's not about a hero or a monster. It's tied to the goddess Demeter. You see, her favorite place on Earth was the island of Sicily, which used to be called Trinacria because of its triangular shape. Well, the story goes that after her daughter Persephone was kidnapped by Hades, Demeter was heartbroken. She begged Zeus to place a symbol of her beloved island in the sky as a memorial. And so, Zeus took the shape of Sicily and raised it to the heavens, creating the Golden Triangle. All right, for our final section, we're going to bring all this theory back down to Earth. This is Triangulum in your telescope, a practical guide to help you go out and see these things for yourself. Because really, the whole point of astronomy isn't just to learn facts, it's to actually see these things. So now, it's your turn. Your turn to become an explorer. So, how do you actually find it? It's pretty straightforward. First, find the constellation Andromeda and look for its bright star, Merak. Triangulum is just a little bit south of there. Now, if you're in a dark location, grab a pair of binoculars and slowly scan the space between Triangulum's 2 brightest stars, Alpha and Beta. You're looking for a very faint, fuzzy smudge of light. If you see it, that's it. That's M33. And as you're looking at it, just take a moment and remember, the photons hitting your eye left that galaxy 3 million years ago. And that brings me to my final question for you. The next time you look up and see that simple shape, that little triangle in the sky, what will you see? Will you just see 3 stars? Or will you see what's really there? A window into deep time, a gateway to an entirely different galaxy, and a story that connects ancient farmers to modern astrophysicists. I'll leave that for you to discover.
Thank you, friends. Strive for understanding and become wiser. See you soon.